Hello, my young and talented physicists. Welcome to class. In our last class, we looked at the concept of specific heat capacity and heat capacity. And we're able to look at the definitions of these concepts as well as their various SI units. We also solved some questions using the formula Q equals NC changing theta. But for today, we shall look at experimental verification of specific heat capacity. We also solve simple problems using the method of mixtures. I remain your host, Ajayi Sunday. Have you ever thought of the effect of a hotter and colder body coming in contact with each other? The hotter body loses heat while the colder body gains heat. And this will continue until the two bodies attain the same temperature. What are our learning outcomes for today's class? At the end of the lesson, you will be able to demonstrate the measurement of specific heat capacity using method of mixtures through an experiment. And the second one is you should be able to solve simple problems using the method of mixtures. And the third, you should be able to mention two significance of specific heat capacity. So let's start by demonstrating the measurement of specific heat capacities using method of mixtures. Now, we need to note that the heat lost by an object is given by MC change in theta. So specific heat capacity is measured using two different methods, namely method of mixture is the first one. In the method of mixture, the heated solid is quickly transferred to a liquid in a well-lagged calorimeter and stirred thoroughly. Specific heat capacity of the solid is obtained from the principle of conservation of energy, meaning heat lost by the hot solid equals heat gained by the liquid and the calorimeter as well. So the second method is the electrical method. In this method, a heater is connected to a power source and it is inserted in the material, be it a liquid or solid, whose specific heat capacity is to be determined. Then the principle of conservation of energy still applies in that instance, meaning electrical heat energy lost by the heater is equal to the heat gained by the heated material. So electrical power can be further broken down to IVT equaling MC change in theta, I being the current, V being the potential difference, and T being the time taken. So you have the formula stated on the screen. Then let's look at the determination of specific heat capacity of a metal using the method of mixture. The calorimeter is brought out of its lagging jackets and weighed empty. It is then filled up to half or two-thirds full of water at room temperature and weighed again. It is replaced inside its jackets and the temperature of water taken. The mass of the solid is also determined. The solid is then hung with a thread in a beaker of boiling water for about 10 minutes to ensure that the solid has attained the temperature of the boiling water, which is taken with a thermometer. The hot solid is now quickly transferred into the calorimeter, shaking it to ensure that no hot water is transferred into the calorimeter. The water in the calorimeter is well stirred and its final temperature taken. The specific heat capacity of the solid is calculated from the following experimental result. So that means the mass of the empty calorimeter is denoted by M1. Mass of the calorimeter with water is denoted by M2. The mass of metal denoted by M3. The initial temperature of water in the calorimeter is denoted by theta1, while the final temperature of water is denoted by theta2. Then the temperature of the mixture itself is denoted by theta3. Specific heat capacity of copper is 400 joules per kilogram per Kelvin, while that of water is 4,200 joules per kilogram per Kelvin. Now, if there's no heat lost to the surroundings, then the heat lost by the solid is equal to the heat gained by the calorimeter as well as the water. And that can be demonstrated using the formula stated on the screen. M3C change in theta equals M1C1 change in theta, then M2 minus M1C2 times change in theta. So, having demonstrated by an experiment the determination of the specific heat capacity of a metal by method of mixtures, let us now apply that formula in solving the following questions. The first example we shall look at is this. The temperatures of water from tab A and tab B are 25 degrees Celsius and 75 degrees Celsius respectively. If a mixture of water at 40 degrees Celsius is required, calculate the ratio of the mass of water from tab A to that of tab B. Now, having known that the heat lost by a hotter body is equal to the heat gained by a colder body. Therefore, heat lost by water from tab B, which is the hotter body, is equal to the heat gained by water from tab A. Mass of the tab B and the specific capacity change in theta equals mass of tab A, specific capacity, then change in theta. Since the specific heat capacity, is the same on both sides, that shows that they will easily cross out. And then we will now substitute our variables, our values into the formula. We shall have MB 75 minus 40 equals MA 40 minus 25. Since we are looking for the ratio of tab A to that of tab B, from the screen here, 7:3 will be the ratio of water from tab A to that of water from tab B. Let us look at another example. A laundering iron rated 400 watts has its temperature increased by 40 degrees Celsius after 2 minutes when connected to an electric mains supply. Calculate the heat capacity of the iron. Now, in calculating the heat capacity of the iron, we shall itemize all the variables from the question. Pi is 400 watts, and change in theta is 40 degrees Celsius. The time taken is 2 minutes, which we need to convert to seconds. So what we need to do is to multiply it by 60, and we're going to have 120 seconds. Then we're looking for our thermal or our heat capacity. Heat lost by the heater in the iron is equal to the heat gained by the iron plates. So that means power times time equals MC change in theta. And we should note that the relationship between heat capacity and specific heat capacity is heat capacity equals mass times specific heat capacity. So it's going to be substituted in this equation. So by the time we substitute our values into that equation, we shall have a thermal capacity or heat capacity as 1,200 joules per Kelvin. Now, having done this, let's consider the significance of specific capacity. Specific heat capacity can be viewed from two different perspectives. The first significance is the land and sea breeze. When we talk about the land and sea breeze, we are looking at a situation whereby the same mass of water with a specific heat capacity of 4,200 joules per kilogram per Kelvin needs more heat to increase its temperature by 1 degree Celsius as compared to the soil with specific heat capacity of 800 joules per kilogram per Kelvin. During the day, you all agree with me that the temperature of the land rises as indicated in the diagram on the screen, more than that of water, causing a current of hot air to move from the land to the sea, while cool breeze blows from the sea to the land. And the land breeze, as the cool air, blows from the land to the sea at night. All these are demonstrated on this picture on the screen. Then the second significance is the choice of liquid coolant. Liquid with high specific heat capacity like water are used as coolants in our car radiators and heat exchangers. So this is because more heat energy is required to increase their temperature. So let's quickly look at these self-assessment exercises. Number one, mention two significance of specific heat capacity. The second one, how long will it take to heat 3 kilograms of water from 28 degrees Celsius to 88 degrees Celsius in an electric heater, taking a current of 6 amperes from an EMF source of 220 volts, given that the specific heat capacity of water is 4,200 joules per kilogram per Kelvin. These are the questions for self-assessments. Then in conclusion, in every heat exchange, if there's no loss of heat to the surroundings, the total heat energy lost by the hot body or hot substance is equal to the total heat energy gained by the cold substance. I want to believe we've been able to gain one or two information or knowledge regarding today's class. I want you to keep a date with me in our subsequent classes. I remain your host, Ajayi Sunday Aina. Continue to keep focused. God bless you. Thank you.